I will try and introduce you to metabolomics and lipidomics and how they may be relevant in the context of rare diseases. And before I should start, I should thank the organisers for the invitation to come to speak to you. Okay, so as Gemma said, really, metabolites are the small molecules that actually we make in our bodies. So they might be signaling molecules like hormones, they might be structural molecules, they might be breakdown products. But the key is that we actually make them in the body. So my favourite small molecule is this one. This is cholesterol. So it's a metabolite, but also it's a lipid. So lipids are fats. So lipids are actually a subsection of the metabolites. So a key point is that the pattern of metabolites and lipids that we see in our body fluids very, very often change in response to a disease. So we might have, if we have a particular disease, that disease might be reflected in our metabolic pattern in our body fluids. So this leads us to the subject of metabolomics and lipidomics. So metabolomics really, it's about measuring the metabolites in a body fluid. And then lipidomics, as I said, that's a subsection of metabolomics, and it's specifically measuring the lipid contents of a biofluid. And we do this in the hope that we can actually make help in making a diagnosis of a disease, maybe a rare disease. So let's just walk you through how these metabolomics and lipidomics work. So we start on the left here with our sample, which is usually plasma or urine, or it could be cerebrospinal fluid. We then separate out the different molecules in the second panel on what we call a liquid chromatography instrument. So that just separates out the molecules. They then go into another instrument, which is called a mass spectrometer. And the mass spectrometer allows us to identify the different molecules, determine their chemical structures, and also measure their concentrations in our sample. And a mass spectrum looks like this in the central the third panel. All those peaks you see, that's a typical mass spectrum. And each one of those molecules, each one of those peaks will be a different molecule. And the height of the peaks is going to be proportional to the concentration of the molecules in our sample. So we can identify the molecules in our sample, and we can determine the concentrations. Once we've identified the molecules, we then try and put them onto what we call a metabolic pathway. So a metabolic pathway is really a reaction scheme of how different molecules are made in our body and then broken down. So on the right, we've got a metabolic pathway. Now, if we've got a rare disease which results in an error in one of the reactions in this metabolic pathway, so maybe one of the reactions in this metabolic pathway is not working correctly. So here I've got my red line. So this is where a reaction is not working correctly. When we have that, then we then see a build-up in the metabolites above the red line and a fall in the metabolites below the red line. Now, metabolomics can then measure this, and then that can pinpoint where the defect is in the metabolic pathway, and hopefully that can lead to a diagnosis. Okay, this all sounds good. However, really, at the moment, metabolomics and lipidomics is really yet to be exploited by the NHS. It's not really moved into the NHS yet. We do have really good expertise in UK universities in metabolomics and lipidomics. And really, what we need to do now is to translate the expertise that we've got in the universities into the NHS. So really go from bench to bedside. So at the moment in Swansea, we're doing a little bit of this. We're working with a clinic in Cardiff, which is called the Syndrome Without a Name Clinic. So this is people who are in the middle of the diagnostic odyssey at the moment. They've got a disease, but the clinicians can't identify what that disease is. So we're looking at patient samples and trying to help the clinicians to make a diagnosis. We're also working with other hospitals looking at these variants of unknown significance when there's a mutation, but we don't know whether it's going to be pathological or not. So we're helping to determine whether these variants of unknown significance are significant or not. Another thing which we can do is monitor response to therapy. And finally, panels of metabolites can be used in newborn screening. So this is something that's really being pushed in the USA and Netherlands, really to improve the diagnostic of rare diseases by newborn screening. Thank you.